Hello, everybody. This is Sunday. It's August 28th, and I want to welcome you to the first module of our online astronomy course. I'm Dr. Brad Carroll, and I'll be making these videos every week to introduce the contents of each module and to tell you some of the latest astronomy news. I hope you've already watched the introductory video for the course. It sort of takes you through the syllabus. I hope you've read the syllabus, because that's where really the explanation of the meat of the course is, in the syllabus, and I walk you through it in that introductory video. So take a look at that. And before we get into the module, I do want to tell you something about some astronomy news that is going on. And that is, by the time you see this, the Artemis 1 will have launched. Artemis 1 will have launched, and it will be going to the moon. It is not a crewed mission, but Artemis 1 will launch Monday morning around 6:30 a.m., 6:33 to be exact. That is Utah time. And this is our first step on returning to the moon. So this is an uncrewed test of the whole system, and this is going to be tested tomorrow and over the next couple days. And if you want to follow it, you can just go to NASA Live on YouTube or something like that. Go to NASA Live and you'll see continuous reports on Artemis 1. Pretty exciting time. I remember the first moon landing back in 1969. I was 20 years old, and I was really excited about that. And I'm equally excited about this program, because we're going to be going back to the moon, and we're going to be staying there in some sort of base to do scientific exploration. Very exciting time. But let's talk about Module 1. And in Module 1, you'll be reading the preview and Chapter 1 in your textbook. Hope you all have your textbook. Exploration, it's by Arne and Schneider. This is the 8th edition, and you may have this, you may have the 7th edition or even the 6th edition. They're all pretty much the same, so I hope you have whatever is cheap for you. And so make sure you read the chapters as we go along here. But this is going to be about the preview and Chapter 1. So the preview is just a tour of the universe. And you have to wonder about the first people. Way before there was a civilization, would look up in the starry sky. Something like this that you see behind me. This is a picture I took almost 6 years ago. I took it at Lassen Volcanic National Park in California. We were camped on the shore of Summit Lake. And in fact, behind me here, over my shoulder, you can see the light that's in my tent at the campground. But it was a beautiful night, no moon, and you could see the Milky Way, which is what you see rising into the sky there behind me. And it was just a glorious, glorious night. Also, there's 2 planets you can see in this image, and they are Saturn and Mars, and they are over here. But we'll be talking a lot about what we're looking at here. What are stars? What are planets? How does all this work? And so we're going to be looking at what is out there, and we're going to be looking at how it got that way. It's a fascinating story, and I think you're going to enjoy it. But we have to go through some preliminaries first. And one of those preliminaries is to tell you that we're going to be using in this course, and in all astronomy courses, the metric system for making measurements. Now, a meter is about a yard. So the length of a meter is about a yard. A meter is 39.37 inches. You don't have to know that. But it's just a tiny bit more than a yard. A kilometer, which is a kilometer, 1,000 meters, is about 2/3 of a mile, 0.62 mile. but you can think of them roughly as a bit shorter than a mile. So that's the sort of thing I want you to keep in mind. Now, when we look here in the sky, we're looking at things that are very far away. We're looking at objects that have took light hundreds and thousands of years to get to us, just looking within our own Milky Way. And we'll find out there's objects in the sky that we can see with our naked eye, where it takes light 2.5 million years to get to us. And so the universe is vast and it's big. And to describe it, we have to use very large numbers. And that means we're going to use powers of 10 notation. And that is scientific notation, it's sometimes called. Instead of writing 2 million as 2 with a comma, 000, comma, 2000, I would say that 2 million was 2 times 10 raised to the 6th power. And that means there's 2, and then with 6 zeros after it is all that means. There's an introduction to scientific or powers of 10 notation in your text, and there's also on the introduction to Module 1 that I wrote, there are some exercises for you to try with your calculator to make sure you know how to manipulate these very large numbers. Now, some of you may be, thinking, oh my gosh, this sounds like math. But here's the deal. To understand our universe, astronomers use math. That's how they have to describe the processes that cause stars to shine, that cause stars to orbit each other, and so on. Now, on the homework, I will have you do some of that math. And I'll always, in the module introductions, show you examples of how to do it. However, there won't be any math on the exams. Well, maybe just some very simple math where you have to recognize the correct way to do the math. But you never have to use a calculator on the exams. You're welcome to have one with you, but you won't need it. Nobody's ever complained about the level of math on the exam. So don't worry. But on the homework, I do want you to see how astronomers go about understanding this amazing universe that we live in. So also, you'll be finding out that astronomers sometimes use words differently. And scientists in general use words differently than we do in ordinary everyday English. Words like work and energy have very specific meanings in astronomy. Also in science, we use words like hypothesis and theory. And those are used too in everyday talk, but they mean something different in science. A hypothesis is, maybe you've heard it's just a guess. And that's fairly accurate, but it's a guess that can be tested. And if you can't test an idea, it's not a scientific idea. Also a theory. Some people, when they hear the word theory, they mean, oh, that's just somebody's opinion. That's just what they think. I have a theory about why my dog escaped from the yard or something like that. I just, I have an idea about how it works. But in science, a theory is the pinnacle of our scientific understanding. It consists of statements that are wide-ranging, far-reaching, and have been tested over and over and over again and found to be valid. Now, we can never prove a theory is absolutely correctly right, because the next test down the road may show there's something a little bit wrong with it. But as far as we know, we are going to be learning about the most firmly established theories in astronomy. So let's start with the night sky. You go out into the night sky, and right here, looking at your screen and looking at the stars in the background, it's as though you were facing south. So just pretend you're outside in your yard facing south. And now, let's stick out if you're facing south, you can just stick out your left arm. So stick out your left arm there. And that arm is pointing east. So if we're looking south on the screen, east is to the left side of the screen. And in the same way, west is to the right side of the screen. So that's just an easy orientation to the night sky. And remember that as the night passes, that stars will rise in the east and they set in the west. Well, so does the moon from night to night. Rises in the east, sets in the west. The sun rises in the east, sets in the west. And that happens, of course, because we are on the rotating Earth. Now, early people, early Greek philosophers didn't realize that. They thought the Earth was motionless and that the whole sky rotated around the Earth, which was at the center of the universe. So they believed in a geocentric solar system. They believed that everything in the sky, the planets, the moon, everything rotated around the Earth. Geo for Earth, centric for center, geocentric solar system. And so we'll be learning a little bit about what the ancient Greeks thought. Today we know it's really because we're on the rotating Earth, and the rotating Earth causes us to see stars rise in the east and set in the west. Just as you were to sit on a rotating stool and spin around, you would see the room spinning around you. It's really you spinning, of course. And we'll be talking about the moon and how the moon has phases. Now, yesterday, Sunday the 27th, was the new moon phase. That was when the moon is closest to being in the direction of the sun. And so we're looking at the dark side of the moon. You know, if I shine a light at any ball, half the ball is going to be lit up and half the ball is going to be in shade. And if the moon is between us and the sun, then the side of the moon facing us is in darkness. And we call that a new moon. And so we're about to start through a new cycle of lunar phases. And so this is a great time to start your first observing project. Now, these observing projects are optional. You don't have to do them. You can get all the points for the course without doing a single observing project, but the observing projects are for extra credit. And if you do, for each one you do right, you get a point. And during the semester, if you get 10 points, that's a full letter grade increase in your final score. So I'll encourage you to start doing the observing projects. And the first one you can do is charting the phases of the moon. So go take a look at that. That's in Module 1 on your course listing of modules. You'll also be learning about eclipses. And there are lunar eclipses and there are solar eclipses. For a lunar eclipse, the moon is in its full moon phase and it moves through Earth's shadow. And it's really cool if you see one, because all of the sunrises and sunsets from all over Earth spill onto the moon, and the moon looks like a glowing red ball. It's really cool. Or we can have a solar eclipse, and that's when the moon moves across the face of the sun. Now, I have a video about moon phases and about eclipses, and I'll invite you to take a look at those. Please take a look at the videos that are in each module. So that's it. We'll be just learning how ancient people looked at the sky. We'll be looking at how the sky moves and how various objects move within it. Now, before I go, I want to pull up Stellarium. So I'm going to do that. Let's find Stellarium here. And Stellarium is a program that we'll be using for some of the observing projects. I'll also be showing you a scene from Stellarium at the end of each of these introductory videos every week. But this is Stellarium. It's something you can download. There's a link on the course homepage. And you can set your location. As for me, it's Ogden in Utah. You can set it for your location. This is set for the year 2022. This is on August 29th. So this is set for Monday night. 23 hours is 11 in the evening, and we're looking south. And just as I said, if we look on the left side of the screen from there, we're looking east. And if we look to the right side of the screen, we're looking west. But right now, because there's no moon, this is a great time to see the Milky Way. And this looks just like you saw in the picture. Here's our Milky Way galaxy. Here's the constellation of Sagittarius. It looks like a little teapot. Here is the body of the teapot. Here is the handle of the teapot. Over here is the spout of the teapot. And here's the lid of the teapot. So Sagittarius looks like a teapot. And if this is the spout, then if it's pouring into the Milky Way, right about here is the center of our Milky Way galaxy. So looking in this direction, you're looking toward the center of our Milky Way. Also over here is the planet Saturn. So the next couple days, when the moon hasn't risen yet, this is a great time to see the Milky Way. But as the week goes on, excuse me, you can see the moon starts to rise. Well, I hope you enjoy learning about early people's view of the universe. And if you have any questions about anything, you can always send me an email. I'll be happy to answer that as soon as I can. Or you can ask, and I can set up a meeting with you. We can meet by Zoom, or you're welcome to drop by my office. So I hope you enjoy learning about the material in this first module, and I'll look forward to seeing you next time. So until then, bye-bye.